Alright, so we're going to look at 5 shortcuts. The side shortcut, the side angle side shortcut, the angle side angle shortcut, the angle side shortcut, and the hypotenuse leg shortcut. These will all be reasons on your test, your proof test. That's all proofs with nothing filled in for you. So you can flip that paper over, and we're going to start right here. Before we get started, I did this last time. We have to understand what this term called included means, right? An included angle and an included side. Does that kind of make sense? So right now, if Mr. Legit is a side and I am a side, who is our included angle? Caroline. Because she is between the two sides. Does that kind of make sense? It has to be between. This angle is between these two sides, so specifically it's called an included angle. It works the other way. I have these two angles marked, and this side is marked, so that side is between two angles. It's called an included side. The first shortcut we're going to discuss is the side shortcut. It's everyone's favorite shortcut. It is the easiest to identify. It says, and it's already written for you, that if 3 sides of one triangle are congruent to 3 sides of another triangle, those 2 triangles are congruent. So this is just a preview of what it will look like. You will see 2 triangles marked with 1, 2, 3 pairs of congruent sides. So you would add those markings to your notes. That's what the side shortcut looks like. Does that say anything about angles? No. But because I have 3 pairs of congruent sides, you can deduce that all the angles are also congruent. Because the side shortcut proves 2 triangles are congruent. And when 2 triangles are congruent, it has 3 pairs of equal sides and 3 pairs of equal angles. Terrified? No? So in the regular class, I teach the kids to do this. Mark it. This side is congruent to this side. This side is congruent to this side. And this side is congruent to this side. And what 3 letters do you have there? The SSS shortcut. So because it has 3 pairs of congruent sides, you have the ability to write a congruency statement. This is what we did on Friday. On Friday, we had to make our checklist and get 3 pairs of congruent angles and 3 pairs of congruent sides. But because we're using shortcuts today, in this instance, we only need the side shortcut. So how would you write a congruency statement for those 2 triangles? So you have to name this triangle.
Side AB and trans ABC.
ABC. Now, remember, order matters. Because I went A, B, C, like this. I went 1, 2, 3. I must do the same thing on this side. D, E, F. Then once you have a congruency statement, then you can identify that angle A and angle B are the same. Angle B and angle E are the same. Angle C and angle F are the same by using that circle technique. So we have to use a shortcut, the side shortcut, to write a congruency statement. This congruency statement is true because of the side shortcut. And once we have this congruency statement, it allows us to deduce the other 3 parts of the missing information. Side shortcut, you guys generally do pretty well with that one because it is just 3 pairs of congruent sides. You will see this one a lot. This is the side angle side shortcut. Now look at it. Where is the A? Between the S's. So it's the definition is two sides and an included angle of one triangle are congruent to two sides and the included angle of another triangle. If that happens, you have congruent triangles. So here's what it looks like. If I pick this side is congruent to this side, and I pick this side is congruent to this side, I have to have an angle included between those two sides. And there is only one angle that can be included. So that's what the side angle side shortcut looks like. And if you use my technique, this side is congruent to this side, this angle is congruent to this angle, and this side is congruent to this side. What shortcut do you have? The side angle side shortcut. What if you read it backwards? What is it? Same thing. So that's what the side angle side shortcut looks like. If you have side angle side shortcut, you can write a congruency statement. And once you have a congruency statement, you can deduce the other three missing pieces of information. That kind of makes sense? Is this too easy or am I going too slow? Or like blank stares right now? Just hang on. We good? All right, here we go. So side angle side, very popular. You will see that quite a few times on your test. Angle side angle, very popular. You guys generally do well with this one. Notice where the S is between the A's. So this one says you have two pairs of congruent angles and one pair of congruent included sides. I'll pick the easy scenario. If angle A is congruent to angle D and angle C is congruent to angle F, the angle side angle shortcut only happens when the side is between the angles. And when you mark it, angle, side, angle is congruent to angle, side, angle. It reads ASA. And backwards it reads ASA. ASA proves congruence. So if you have the angle side angle shortcut, you can write a congruency statement. Once you write a congruency statement, you can deduce the other three missing pieces of information. Is it clicking?
Yes.
No, it's not. This one's tough. Okay, this is the AAS shortcut, or if you read it backwards, the SAA shortcut, because it's read forwards and backwards differently. Now this one is, notice where the S is now. It's outside of the angles. So you need two congruent angles. And now the side has to not be between the angles. This can offer a little bit of difficulty. You see how there's two possible answers now. So I'm just going to choose this one down here. That is what the angle side shortcut looks like. And it's read angle side forwards or side angle backwards. Both of those prove congruence. Then you can write a congruency statement. And once you write a congruency statement, you can deduce the other three missing pieces of information. Okay? Ready? HA. Glaringly different. Glaringly different. Why?
Because it gives you two angles.
There's no S's and there's no A's anymore, are there? Now what are the two letters? H and L. And it's just two letters. It's just H and L. So this works for right triangles. Okay, do you have a hypotenuse if you don't have a right triangle? Or what is the only shape that has a hypotenuse? A right triangle. So when you have a right triangle, the HL theorem is possible. And it just says you have a pair of congruent hypotenuses and a pair of congruent legs. Because they're right triangles, we don't have things called side angles anymore. A hypotenuse is explicitly described as a hypotenuse and a leg. Kind of makes sense? So, if you ever use the HL theorem in a proof, you have to state that you have right triangles. So you have to say triangle ABC is a right triangle. Triangle DEF is a right triangle. That way I know you have a hypotenuse and you have a leg. Now, what does not prove congruence? Angle, angle, angle does not prove congruence. So here's my equilateral triangle tool. It draws equilateral triangles every time, all the time. Those two triangles are equilateral triangles. 60, 60, and 60. But are those two triangles congruent? No. So these have three pairs of congruent angles, but they are obviously not congruent triangles. Angle, angle, angle is not a congruency shortcut. And SSA is not a congruency shortcut. Or if you read it backwards, you get the other word, ASS. Okay. So here's why ASS doesn't prove anything, okay? Let's just watch this. If I go back to this triangle, and don't write anything on your notes, please. If I go back to this triangle and mark it as just a regular triangle, notice how I have these angles are congruent, and these sides are congruent, and these sides are congruent. That says ASS. But ASS does not prove congruence. That's why we have hypotenuse leg.
Are you there?
Hello. What's up? I do. I will. Thanks. Jonas, I was to talk to you in Grand Canyon hallway. So ASS does not prove congruence, but HL does. All right? Yeah, probably. Is everybody thoroughly intelligent now?
Wait.
Wait.
Why does ASS not prove congruence?
Because it looks like just the same thing. As
It does. Okay. Okay. Here we go. Hold on. I can do this. Nope. This is a hard one to prove. Okay, right here. So this is a scalene triangle. It has side measurements of 3, 5, 9, and it has a 60-degree angle right here. That would be, if I drew another scalene triangle that had a 60-degree angle right here, this was 5, this is 3. See how it's ASS and ASS? And notice how those are two different triangles? So that's why it doesn't work. Because this angle up here, or really this angle right here, could be, it's called reflected across an altitude, and it creates different triangles. That's why ASS doesn't work. Now, I know you guys are freaking out a little bit, but you're going to see questions, and everything's going to be marked for you already. So I'm asking you guys this: what shortcut is that? ASA. Does that alleviate any stress? Okay. You might see this shortcut right here. Are those two triangles congruent? Yes. Why are they congruent?
What have the markings on?
Yes. Now, there could be a scenario where it looks like this.
Wouldn't that be reflection?
So if I gave you this, What shortcut proves that those two triangles are congruent?
Angle side.
So I understand that this angle and this angle are congruent. I understand that this angle and this angle are congruent. But where are you getting that side? Right here? So in a proof, you have to say that AC is congruent to AC and justify why those two things are congruent. The reflexive property. Now you have undoubtedly a third side that's congruent, so you can say the ASA shortcut. Does that kind of make sense? What really screws with people is one like this. So what is this one?
Angle side.
And what is this one?
Side.
Do those even match? See, they don't match. They do not
Then
prove
what would you do?
congruent. They don't prove congruent. You just say no, they don't work. Doesn't work. What shortcut is that? That's the side shortcut. Even though it's not marked, it is true.
Oh, yeah.
Because it's the reflexive property. They're gonna browbeat you guys with that one a lot, right? In the other popular scenario, what if I told you
It's an angle. It's ASA.
so you have to student justify that these two angles are congruent, and then what do you see? The angle shortcut because of vertical. Okay, so we're going to jump into the notes for today, specifically looking at two different shortcuts. So in this question, and I just want you guys to watch these. Don't write any of this stuff down right now. It says, what additional piece of information do you need to prove that these two triangles are congruent?
Another angle.
Okay, right now I have this angle that is congruent to this angle.
Other side.
I have the reflexive sides that are congruent. And I'm trying to use the side angle side shortcut.
Another side.
Now, there is a right side and there is a wrong side.
Yeah.
So I have this side is congruent to this side. I have this angle is congruent to this angle. What's the other side that I need?
RT. Yeah.
I have to choose this side and this side. If I chose the other side, it would be the ASS shortcut, and it wouldn't prove anything. Does that kind of make sense? So it is keen, you guys, to see that the angle has to be included between the two sides that you pick. What about this one? What additional piece of information do you need to prove that those two triangles are congruent by the side angle side shortcut?
Angle E and angle B.
Perfect. So you have to be able to say that these two are congruent.
Would you just draw that on there? Just
On the test, it would ask you just write that in, angle B, and you could draw it in to see it. Now, here's something that's more pre-AP specific. And we're not going to write this one down. It says, here's a proof. So in this proof, and I'm trying to teach you guys how to really master this test, you have to look at that picture and somehow think, what shortcut do you think would prove that those two triangles are congruent? You think it's going to be the side angle side shortcut. I see you seeing this right here. So we're going to have to write that down and justify why all that is true. So you would write, and you want to use the side angle side shortcut. So when you do your proof, do you have a pair of congruent sides?
Yes.
Which ones are they?
JA and AC.
Why is that true? Do you have a pair of congruent angles?
Yes.
Which one?
Angle A. What did you wait? Oh wait, no, it didn't show.
Are we seeing it?
Yes.
Why are those two angles congruent?
Vertical.
So you write the reason is vertical angles. Do we have another side that's congruent?
AJ
Now you're wondering, why did I write it out of order? Because what shortcut did I want to use?
side and side.
So do you have the side angle side shortcut?
Yes.
So you have the ability to say these two triangles are congruent,
Side and side.
and the reason they are congruent is the side angle side shortcut. That's what your proofs will look like on your test. That kind of makes sense? So this is the only new piece of information. Given vertical angles, given, and what shortcut solidifies that.
Side.
Okay? So let's try another one just for me. You don't have to write it down. This is garbage. What about this one? Let's just talk through this one. What shortcut do you think is going to work here?
Side and side.
You think side angle side. So you're justifying that these are the same? Vertical angles? And
And
you think that these are the same?
because O is the midpoint, which means
So as we write that down, PO is a side, is congruent to SO. Why is that true? Given. We need an angle statement.
angle POI is congruent to angle TOS.
Because you went,
Oh yeah.
that's cool, right? Why?
Vertical.
And even if you don't know if this is true or not, you're guessing that side NO is congruent to side OT. So you could write that down in your test and get credit for it, but why?
Definitions are midpoint.
Because O is the midpoint, it is equidistant from both sides, it creates two equal pieces here. So you put definition of a midpoint. Do you have a shortcut?
Yes.
So it proves triangle NOP is congruent to triangle TOS. Why?
Side angle side.
The side angle side shortcut proves those two are congruent. You kind of see how it works. So you have to really front load these proofs. All right, so we're going to do these together. Boom. You might want to write these down. I don't know. I'll give you a little bit of time to write it. The more proofs we do, the less complicated, the less scary this test is going to be. So you're going to have to draw the picture, and you're going to have to write the given statements. So at the end of the day, guys, they're telling you that it is possible for these two triangles to be congruent. Okay? So your proof should end with a triangle congruent statement. Now if you look at that proof and you kind of predict your future, do you think that those two triangles are congruent?
Yes.
What shortcut do you think it is? So we have one pair of congruent sides, we have two pairs of congruent sides, and we need to justify why the third side is congruent to itself. Now, we've kind of predicted our future. We want to use the side shortcut. We have to list all the information down so we can do that. So statement one, what do you want to put?
Line KL is congruent to line KL.
Line segment KL is congruent to line segment NL. Now I'm going to write that as one statement because I know that is a side statement. The reason it's true, okay, statement number two,
Line segment KM is congruent to line segment NM.
why is that true? There's also a side statement. So at this point, we've run out of given statements to describe. And then you said,
Wait, would you say line LM is, or line segment LM is congruent to line segment LM?
yes, and we have to justify why this is true.
It's like
And it is just the reflexive property. And that is also a side statement. So what shortcut have we generated? So what is our last statement?
Triangle KL is congruent to
Why are those two triangles congruent? Because of the side shortcut. Is it really that bad? It's not really that bad. It'll take you longer to draw these than it will for you to actually prove them. So, don't make the last statement harder than it has to be. You're just copying what you're trying to prove. Okay? And if you copy the congruency statement incorrectly, I have to take points for it. Alright, so take a break. Take a break. Let's watch Baker do this one together. It says prove triangle VWX and triangle V or WVZ. WVZ. Prove that the red triangle and the blue triangle are congruent to each other. Okay, so you're gonna predict the side shortcut. So right now I have Vx is congruent to Vz, Vwx is congruent to Vz. This side is congruent to this side. I'll write that down. Wx is congruent to Vz. It also says that Wy is congruent to Vy. That's this piece right here and this piece right here. It's really confusing, isn't it?
I just feel like there's so much going on.
There's a lot going on. So at the end of the day, we have to prove that this side, this triangle is congruent to this triangle.
Where do you send the line?
Where?
Like it has the dash.
Yeah, so that's what we're writing down. And you'll see why in a second.
Because technically stuff
Okay, so in order for this proof to work, does it say that WZ is congruent to VX? We don't have a statement saying that this side is congruent to this side. We don't have that yet. But do we have the ability to write that? Yes, we do. So we can convert those lines. We have to student input that this line and this line are congruent. So how would you go about doing that?
Segment VY plus segment YX is
Right.
congruent to
Vy plus yx equals
ZY.
vx. So why does this piece plus this piece equal the whole thing? The segment addition function. So if I do that for this line, I should probably do that for this line, right? Wy plus yz equals wz. Why is that true?
Segment addition function. VX is
You ready for this? Now I'm going to say that Wy plus yz equals vx. Substitution. I'm going to take these out and put these in because they are already listed as congruent. So substitution. And then I'm going to use the transitive property to connect these two statements. If Wy plus yz equals wz and Wy plus yz equals vx, I can say those two things are congruent to each other by the transitive property. So wz is congruent to vx, transitive property. So right now, I have a side statement, and I got all the way down here to have a side statement. So I've proven that this line and this line are congruent. I proved that the two green lines are congruent. What's the last piece that I
WV
missed?
is congruent to WB.
Then I can say that WV is congruent to WV. Why is that true?
Reflexive.
That is my third side.
And BWX is congruent to WBZ. Sides.
So
So when this proof started, there was a bunch of stuff marked everywhere. Now look, right now, Caroline, undoubtedly these are marked as congruent, right? So that is a side. And we can say that these two are congruent to each other. That is a side. The last part is proving that this piece is congruent to this piece. So what I said was this piece plus this piece equals the whole thing. This piece plus this piece equals the whole thing. And then I substituted this piece for this piece and this piece for this piece so I could write the transitive property. It was this one right here. I used, this is the statement that would confuse people, that Wy plus yz equals vx. So saying that this piece plus this piece equals this whole thing, because they're congruent, you can substitute out pieces that are the same. And once you write that statement, you can use the transitive property vx, repeated, deleted, wz. Now I know the two purple lines
Is
are
this gonna
congruent.
be like on a test something? That is
Like these are test type questions.
like that.
All to get to this. Side, shortcut.
No.
Let's try another one. Last one. Go ahead and write it down. Yeah.
No.
Yeah. Wait, we have to write down proofs.
The whole test is a blank. I showed it to you, didn't I?
No, but
Yeah.
like writing those, like writing the shapes and stuff.
No.
I just don't want to write down the shapes.
You don't want to draw.
Exactly.
Last year, I think I printed this stuff out. So here's the test. Shape, and then just blank.
Oh,
Is that what
are
we're
there
doing on
given
Thursday?
statements?
No, this is your test.
Are there given statements?
Yeah.
Oh.
So it looks just like this, and I went as far as to even give you the number of blanks that you have to fill out. So there's a lot of opportunity to get points, free points, by writing down what you have. We're trying to prove that ABC and triangle CDA are the exact same triangle.
Oh.
But how?
Angle side.
You're saying angle,
Or not-
side,
not,
angle.
Side
It's
angle
just
side.
one side.
Okay, so right now, and this is the problem. We have just one side proven to be congruent. So even if you don't know how to do this, you get points for writing down that BC is congruent to DA and BC is parallel to AD. Why are those two statements
Given.
given? Why are those two lines parallel? Given. Now, what is the next most glaringly obvious thing that you see?
There's like
Angle side.
You see that? You see it? Like that's the glaringly most obvious thing that you see?
what?
I see this part right here. I see this.
Oh.
Right?
Oh, so it's gonna be side.
AD is congruent to AD.
Yeah.
Now, obvious to see that. Now the last part is
Ain't like
okay. So you have to pick the right angle. Which one are we picking? This one? This one?
Yeah. And one.
So you have to be able to correctly name those angles on your test. No, before you get to that part.
CAD.
Angle, you're going to go CAD. So because you went CAD, now you have to do
ACB.
BCA.
Because it has
So you had
doesn't
C, marked angle, marked side.
B.
Oh,
So it should be ACB. You're up. Does it really matter?
yeah. Yes.
Not really. Now knowing why those two angles are congruent,
Alternate.
yeah. So you get points for this, but really, those are alternate interior angles. So I heard a good trick. Color the parallel lines, color the transversal. This angle is created by those two colored lines. This angle is created by those two colored lines. So those are your alternate interior angles. Now if you go back and use my trick, you have a side statement here, you have a side statement here, and you have an angle statement here. But is it the ASS shortcut? No. According to your picture, what shortcut is it?
No.
It's the side angle side shortcut. Does side angle side prove congruent?
Yes.
Yes. So I can write the last statement. I know for a fact this is true. I know it's true because the side angle side shortcut says it's true. Alright, so for this homework, guys, this is gonna be a joke for you right here, these questions.
like easy.